So we're going to go over the slope of a graph, and it's very important to realize that there's different ways to find the slopes of a graph, of a table, of 2 points. So we're going to look at all three examples, but we're going to start off with the slope of a graph. So if we're looking at a graph, it's important to realize that we're going to count from one point to the next to see how many we're going up and how many we're going over. In our fraction, the amount that we go up will be in the numerator, the amount that we go over will be in the denominator. Within that, it's very important to note that if we're going up and to the right, we are going to want to have a positive slope. If we're going up and to the left, we're going to have a negative slope. So these two are very important to make sure we have the right number, right positive or negative number when we're completing these problems. So let's take a look at an example problem so we can make sure we know how to complete this for a graph. So if we have this problem, we're going to look from point B to point A. How many are we going up? How many are we going over? So let's count. I'm going up 1, so that's going to be my numerator. It's going to be 1. And how many am I going over? I'm going over 1, 2, 3. So my denominator is going to be 3. Because we are going up and to the right, it's going to stay as that positive slope. So from now one point B to point A, we have a slope of 1/3. So that means this line has a slope of 1/3. Let's take a look at another problem so we can see how to do it with a different case. So for this next problem, we're going to go from point A to point B. So I'm going to see for point A, how many am I going up? 1, 2, 3. And I'm going over 1, 2, 3, 4. So my numerator is going to be 3, and my denominator is going to be 4. However, because we're going up and to the left, this is going to be a negative slope. So my slope for this problem is going to be -3/4. So every time I give you a graph, you either have to find points on the line, or I'm going to give you 2 of these points, and you're going to count how many you have to go up and how many you have to go over. Now let's take a look at a problem when we are doing a table. So if I gave you a table, we have to think back to where have we seen a table before? We've seen a table before for linearity, and I would give you a table and I would say, is this linear? Is it not? And we would use a special term. We would use the constant rate of change. Well, conveniently enough, the constant rate of change and slope are the same exact thing. The only difference here is the slope is when you definitely have a line, when something's definitely linear. So if I give you a table and I ask you to find the slope, you know this is linear already, so you're just going to give me the constant rate of change, and you only have to check the first 2 numbers. So I see on my y side, I'm going up by 3. On my x side, I'm going down by 2. So we know that the slope, or the constant rate of change, is our change in y's over our change in x's. So our slope is going to be -3/2. We found that our constant rate of change is -3/2, so our slope is also -3/2. So all we're doing is using what we did before to find the constant rate of change. Let's take a look at some problems where I give you 2 points and see what we have to do. So if I give you 2 points, you need to know the slope formula. But what is the slope formula? The slope formula is m, which we saw as our slope. We saw this inside our slope-intercept formula. M equals y2 minus y1 over x2 minus x1. And this is a very important equation. You're going to see this from Math 8 to algebra, all the way into your higher level math classes. So this is something we have to memorize. We have to have in our memory log so we can pull this out when we're trying to find the slope between 2 points. These are subscripts though. These are not exponents. This is not saying y squared. This is saying my second y minus my first y over my second x minus my first x. So every time I give you a problem, I say it's best to label our x's and y's. So for example, if I have -13, 16, and -120, I would label this as my first x, so x1, my first y, my second x, and my second y. So we have my first x, so x1, y1, x2, y2. Now we are going to plug this into our equation. So it says our y2, so our second y, which is 20, minus our first y, which is 16, divided by our second x, which is negative 1, minus our first x, which is negative 13. The reason I put this in parentheses is because this minus sign is not indicating that we're just going to leave that number as a negative. We're changing the sign of our first x value or our first y value. We're changing the sign of it. So we're not just saying it's already negative, we're going to leave that minus there. Nope, we have to do a minus a negative, which we know becomes a plus. So now we have a plus here. So our numerator is 4 divided by our denominator, which is 12. So now we have 4 divided by 12. But that's not simplified. We need our simplified slope. Why would we want to go up 4 and over 12 when we could go up 1 and over 3? So we have to have simplified version because if we are calculating slope, if we are drawing a line on a graph, we don't want to have to go up 4 over 12. You're probably not going to have enough lines or room on your coordinate plane, so to go up 1 over 3 is so much more accurate. Let's see another problem to try to plug in and see if we are able to use this properly. So we have these 2 points. Our first step, as always, is to label. So we have x1, y1, x2, y2. So we have our formula. Our second y is negative 9, minus our first y is negative 19, over our second x, which is 8, minus our first x, which is 14. Once again, a minus and negative is a plus. So we have negative 9 plus 19, which gives me a 10. 8 minus 14 is a negative 6. Like we saw before, we have to simplify. We're not going to leave that in a bigger fraction than we have to, so that it becomes negative 5/3. So as you can see, it's very important that we know our integer operations. We know how to add and subtract with negative integers. If we're not able to do that, we're going to get this problem wrong, so that's why that was a key point when we took 7th grade math. We're going to take a look at some special cases to see what makes them so special and what happens in those problems. So now we have our special cases, and within these problems, you're going to see that we have points that we get to that we're like, wait, that's a little bit weird, but I'll show you exactly what to do once we get to that step. So let's take a look at this problem. We have 8/18 and negative 12/18. We have to use our equation like we saw before. We have m equals y2 minus y1 over x2 minus x1. So we're going to label x1, y1, x2, y2. So our second y is 18. Our first y is 18. Divided by our second x is negative 12 minus our first x, which is 8. 18 minus 18 is 0. Divided by negative 12 minus 8 is negative 20. When I put that in my calculator, I get a slope of 0. A slope of 0 is okay. It's okay to get a slope of 0. This just means that our line is a horizontal line. It's going to have an equation of y equals a certain number. Of course, we're not creating equations right now, but this is good to know as we're moving on that it's going to be y equals a number. And if we look, both our y's are the same value. So for this specific one, it'd be y equals 18. Y equals 18 has a slope of 0, so everything is checking out. But if we get a slope of 0, we always want to double check. Are our y's the same? Yes, okay, that makes sense. If our numbers are not the same though, we clearly did something wrong. So we have to be cautious of that and know when we're using our 0 slope. Let's take a look at another special case and see what's going on over here. So we have negative 17, 19, negative 17 and 5, x1, y1, x2, y2. So we have 5 minus 19 divided by negative 17 minus a negative 17. So 5 minus 9 is negative 14. Divided by negative 17 minus a negative 17 gives me a 0. When I plug this into my calculator, I get an error. We're not going to have an error slope. However, this is a different term we call undefined. We have an undefined slope, and this is when we have a vertical line. The vertical line has an equation of x equals a certain number. If we look at our example, it's going to be x equals negative 17. This checks out. If we have an undefined slope, our x values have to be the same. If they're not, once again, we did something wrong. So I like to call these my special cases because we have 0 and an undefined slope. Those are a little bit weird. However, if we take a look and they have the same number in our x value or the same number in our y value, then we did something right. We're all good to go. So I hope these type of problems help show you how to find the slope of 2 points, of a table, of a graph, and you're able to apply them and notice that they're all the same thing. We're just taking different routes to get there.